Hey guys, this is going to be the last video that I'm going to do over chapter 1, and then we're going to get into the other stuff right here, so be seeing you real soon. I'm going to give you a problem that's real important to do because it has and shows a lot of the pitfalls that you can see in science in general when we're doing measurement stuff, especially sig figs and unit conversions. Okay, so a few things to point out before we get there is temperature. So on the unit and temperature, I just wanted you to do some stuff on looking at how to convert Celsius to Fahrenheit. The only thing you're going to have to do with that is we'll do a lot of conversion from Celsius to Kelvin. A lot of formulas, we have to have it in the actual Kelvin scale, and all that means is you take your Celsius temperature and add 273. You subtract 273 if you're going the other way around. This one, the last part of this section, 1.9, where you start having to do some sketches. Those are going to be a little rough at first, but that's actually a pretty big part of AP chemistry now. And so I'm going to wait to where we can compare different classifications of matter and physical changes with the chemical ones and show what they're expecting you to demonstrate to them in terms of your understanding at the atomic level. Now, the problem I'm going to give you is this guy right here. Okay? So this is a pretty big problem that has a lot of the stuff I'm talking about, and if you can do this, then you understand how to apply all this stuff in terms of working with numbers in chapter 1. Okay, so if you get exactly the right answer all the way through this, that's a really good sign. But you want to stop, try to do this problem on your own, and then you can listen to my explanation on this stuff. I don't know why there's this line in here after the K, that something that kind of randomly showed up. I'll have to try to see if I can get that fixed. But that's not that big a deal right now. All right, so how do we deal with this? So we have a student was given, or actually a group of students, had 3 samples of sulfuric acid, and they got to figure out the average density of these of the entire amount of sulfuric acid they have. So they're going to have to take the total mass and the total volume, but it was in 3 different containers, and so each one of them went and got the mass and the volume with the measuring devices that they had available. So this first one right here, okay, we'll say Michael was student number 1 right here, and he threw it on a scale. It's a decent scale, okay, we've got him to measure out to the 10th place. And he did the measurements on the volume very, very accurately. So he used something that we're going to use quite a bit in here. This is called a burette. This is actually a $100 piece of glassware that can measure down to the 100th of a gram. Yeah, so you can go out there 100th of a milliliter, which if it's water, it actually would be 100th of a gram. So incredible accuracy on that. This next student right here, they used the better scale, but they didn't have access to as good. I don't know why it does that. Let's see if we can get that off there. Okay. But they didn't have access to the burette, so they used a graduating cylinder. All right, so this graduated cylinder right here measures out to the milliliter, so you can see that right there. And they did happen to remember to estimate to the 10th place, so that's pretty good. Our third student right here, so let's say student number 2 is Connor. Student number 3 right here, this is going to be Jordan. None of the good equipment was left over, so you had to use kind of the crappy freshman spring scale. Threw that on there. And for a measuring device for volume, all that was left is this wonderful plastic middle school graduated cylinder that all it does is measure to 20 milliliter spaces, and so we got kind of a bad number on that one right there. All right, so now what we have to do is we have to add up all these masses and add up all the volumes and take the total mass divided by the total volume. But because these didn't use the same measuring devices, we're going to be really limited as to how many sig figs we keep, and we've got to follow the rules. Students don't usually screw up multiplication division rules. They're really easy because whichever measurement has the least sig figs, that's how many you round your final answer to. Addition and subtraction is different. It's all about how many decimal places out you can actually keep the number. All right, so I'm going to move this up a little bit. And I don't know why this keyboard's on there. See if I can get rid of that. Yay, it's gone. So first off, what you want to do, and they don't necessarily show you how to do this, is it's a really good idea if you have a set of numbers you're adding up to line up your decimals on those, because that'll really help you with rounding this off to the proper number of sig figs. All right, so let's see what we can do with this. Okay. This will also start showing up for us why it's important to use really good measuring devices, because if you have one bad measuring device in there, it can really limit how many sig figs you can keep and screw up the entire thing. So let's go ahead and add this up. So columns are right there. Okay, so hopefully I did the math right here. So we've got, I get 162.95 grams. Now, here's the thing. You can't use that number. What you do is, the reason I like to line up these columns right here is, there's my decimal place. I didn't put the line right there because that's where the decimal place is. I put that line right there because this is where I don't know exactly what the numbers are. So if I don't know what those numbers are, because the measuring device doesn't have that kind of precision, I can't say for sure what those numbers are right there. So the number I'm going to be able to use in my math isn't going to be 162.95 grams. I'm going to have to use 163. I can't keep those numbers. So my actual number, 163 grams. Okay? So, and it's not because I had 3 sig figs in all my answers, it's because that's where the decimal lined up. All right, now let's take a look at our volume numbers here. Again, I'm going to rewrite this stuff so that I can see where the decimal lines up. Okay, and there's a decimal right there that we don't see. All right, if we take a look at this, we just go ahead and do the math again. Carry the 1, 12, 13. Okay. 163.02. So I have to do my addition and subtraction first before I do my division to see if I've got the right number of sig figs and the numbers I'm going to use for my division part. Well, if I take a look right here, now again, I lined this up. All of a sudden right here, I don't know numbers. Well, I got to be careful right here. This might not be exactly the way you think right here. So I don't know what that number is. I don't know what this number is or this number. That 0 is a very problematic 0. Because it's not in scientific notation, I'm not sure if that 0 is significant or not. So if you watched an earlier video, zeros, unless they're final zeros or the right of the decimal or sandwich, give us a real problem. I have to, without knowing specifically how the person measured this thing, say that that value right there is insignificant. This creates an issue right here. So as soon as I've got anything in my column that I don't know, I can't say with any certainty what that number is that's in that column. So I don't know that 3 for sure. That's what I like to do right here. That's where my dotted line goes. Now that doesn't mean I turn 163.02 into 16. What that does mean is I'm going to have to say 160. Because I don't know if that 0 or if this 3 right here was significant, because I don't know if that's 0. Is it supposed to be 1? I really don't know. So a person needs to express that number a little bit better. Now what can I also do? Well, I can do my next step in my math. And another thing with this is I would highly recommend that when you're doing this stuff that you keep the units in there so that you have the right thing. Another thing to point out is a milliliter is not an SI unit. A milliliter is actually a cubic centimeter. So if you have a centimeter by a centimeter by a centimeter, that gives you 1 cubic centimeter. That's how we've defined a milliliter. Then go ahead and do your math right here. All right. So 163 divided by 160 gives me this big old number. 1.01875, and the units would be grams per milliliter. Okay, isn't showing up the best right there, but you get the idea. All right, now how many of those numbers can I actually keep? Well, the 163 had 3 sig figs. The 160 had only 2 sig figs that I know for sure. So what do I have to do with this right here? I have to only keep 2 sig figs in my answer, so I'd say 1.0 grams per milliliter. If we have a problem where sig figs is the thing that they're looking at, this is the only correct answer that you can get for this right here. You can't say 1.02. That would be 3 sig figs, and because of that one problem way back earlier, we don't know for sure if that's true. So this is show you some of the pitfalls you can have in sig figs. One of the things that would have been a lot better is if people coordinate and everybody's using the same measuring devices originally when you're collecting your data. So when you guys get in the lab, that's going to be important, and also everybody is estimating that last position for the proper number of sig figs in that measuring device, so we get as much precision as possible. Students who take their time and take careful measurements do a lot better, because all these little mistakes will add up to big errors by the time that you get done with the problem. Okay, I'm going to pause it here and so I can bring up another screen to show you how to do the conversion, because it's actually a pretty tough conversion from grams per cubic centimeter or milliliter, it's the same unit, into, I believe we did decigrams per kilometer cubed, which isn't really a unit we'd use, but I wanted to give you kind of a difficult conversion.